This is a previous quiz for reaction turbine, Francis turbine. No? Um, the following circumstances govern the operation of reaction turbine with runner. Usually that will be a 600 mm. So let me try to bring down here the schematic diagram of our call this the velocity diagram of my reaction turbine. Now I have here the radius 1, so this will be the outlet. So this will be equal to 600 mm. No? And if you will try to convert this one in terms of meter, so this will be 0.6 in terms of meter. Then, and we have a 200 mm. So this is the inlet radius. So we have the radius 2. No? So this is equal to 200 mm, or it will be, you can say that this will be 0.2 in terms of meter. And we have the given RPM, so we have the rotation here of your reaction turbine. So given the RPM, which is 200 no RPM, okay. And for the angle of attack, we have initially this is 35 degrees. So if we'll try to zoom in, so for my 35 degrees, so ito yon. This is my 35 degrees inlet. So let's try to zoom in this out and zoom out natin. Then for my ano naman call this for my outlet, so it will be 85 degrees. So ito yung part na yon, which is your 85 degrees. So angle 2. So this is 85 degrees. No? Then the given also stated that we have called this 50% no? For your turbine efficiency. No? We have here. Sorry, this one. If we given, we have 50%. So for the turbine efficiency, so that will be 50%. And we have your 10 mm vane inlet thickness. So at this point, so that will be vane inlet thickness, so that will be sub 1, that will be 10 mm. Okay. And then we have 50 mm vane outlet thickness. So ito yung part na yun. So that will be my B sub 2. So that will be 10 mm, 50 mm. Now converting this one, so this will be 0.01 in terms of meter. And this is 0.05 in terms of meter. And we have the water velocity within 300 mm diameter input penstock. No? Now, for the input penstock, so I have here, bring down here the schematic diagram. So just a 2D representation. No? Usually, we have here the turbine, no, for our reaction turbine. So it's located here the below, and we have here the location of your source, or it can be the head, or that is providing the power that is being absorbed by the turbine. Now, yung problem states that we have the penstock. So ito yung penstock na yan. So this is my penstock, so, tinatawag, no? This is what we call the penstock. Now, the penstock has a given diameter, which is from the problem says it has 300 mm. Okay, 300 mm, or say that will be 0.3 in terms of meter, and it has a correspondingly velocity which is recorded that will be being monitored as a velocity of 8 meter per second. No? Now, the problem is we're looking for your, we need to compute, no? Uh, we need to compute um, the relative velocity at the inlet. Now, if you're going to refer to the velocity triangle, no, so this one, if we try to check the velocity triangle initially, now we're looking for the relative velocity. If you're going to draw the velocity triangle, so we have here the relative velocity, no, and so at point one. Now, also, for the part B or letter B, we're looking for the absolute velocity. Now, for the absolute velocity, this is the absolute velocity v sub 1, which is an angle of attack of 35, which makes an angle of 35 degrees from the tangent of motion of the fluid. Then, for letter D, we're looking for the tangential velocity of the outlet. So, for the tangential velocity of the outlet, so we have here BT T2 at the outlet. Okay, so the angle is given, and we can merely solve the normal velocity here by using the Boolean flow rate, which is 2 phi radius thickness of the vane, and we have your normal velocity. So we'll try to show that one later on. Then it's absolute velocity at the outlet, so absolute velocity. So this will be the line of the velocity, absolute velocity of the fluid that is leaving from the vane to. Then we have to determine the torque. So again, using the Euler's equation to determine the torque, so we can apply that one. Then the work done by the turbine, so that is the angular velocity, the torque is being multiplied by the angular velocity. So we can get the work done by the turbine. And finally we have your head produced by the water and the head of the water. So it would be how much is the work the work produced by the water and the head. That will be the elevation, no? How much is the elevation that is changed from starting from the elevation here and at this point. So how much is the change, no? So that will be the head that is producing the power to absorb in the turbine, no? Now, from the previous lecture, I have derived also already also that we have this following arrangement of the equation. So we have here the cotangent of alpha 1, which is in this angle, and this is equal to the 2 phi radius 1 square times the thickness of the vane and the angular velocity all over divided by the Boolean flow rate plus the cotangent of beta 1. So that will be the angle of your relative velocity mixed with the tangential velocity of the fluid. No? Now, if we'll try to examine this equation, um, what is given to the problem is that we have the value of cotangent alpha, we have the radius, we have the thickness of the vane, and the angular velocity can be computed from the equation that is 2 pi n, no? And the Boolean flow rate, we need to determine it from the Boolean flow rate of your penstock. So it can be solved as the area times the velocity. Then for the beta 1 is unknown. So ito yung hahanapin natin in order to solve the value of my relative velocity at this side. No? So, first things first, let's try to solve muna yung call this the Boolean flow rate. Okay? So, in order to do that, we have the equation for the Boolean flow rate of the penstock. So, that will be yung Q. So, that is equal to your area times the velocity. And this can be expressed as in terms since penstock that is circular. So, that will be pi over 4. Then, given that the diameter is a 0.3, so I can substitute it directly, and this will be squared. And given that the velocity of the water at the penstock is being monitored as 8 meter per second. Okay? Now, pressing my calculator, the value of this one is equal to 0.0 0.565 cubic meter per second. Now, let's try to substitute yung mga values ng nakuha natin, no? So, and also what is given. So, that will be cotangent. The alpha one, so we have the 30 degrees. So, I will try to express my cotangent here since cotangent is is also equal to 1 over my tangent. So, that we can press this one. Madaling i-press sa calculator. It will be 1 over my tangent, no? So that will be 1 over my tangent with the angle of, we have your 35 degrees. And this is equal to my 2 phi. It will be 2 phi. Then the radius, 1, that will be equal to 0.6. It will be meter squared. For the thickness, we have the thickness of my vein initially. So we have 0.01. So it will be 0.01 in terms of meter. Radius, then next we're going to substitute the angular velocity. So that will be, again, that will be 2 phi. And we have your RPM, that will be 200. So this is in terms of rev per minute, no? Then I'm gonna multiply this one in terms of convert this one in terms of seconds. Okay, and this is all over, no? All over. So it will be all over divided by the given value of volume flow rate, that will be 0.565. So this is in cubic meter per second. Okay, then I'm gonna plus here from the equation that is cotangent, that will be 1, no? 1 over my tangent. And the beta, which is unknown to the problem, so we need to determine that one para magkaroon tayo ng value ng in order to solve the relative velocity. Okay? Now, pressing my calculator, shift solve, no? We may able to determine that the value of my beta, no? Beta 1 or the angle using my shift solve in the calculator. So that is equal to 59.79 degrees, or let's say we can round this up to 60 degrees. Now, I have drawn here, I magnify yung velocity triangle dito ng inlet, no? So, I have my inlet here. This is my beta 1. Okay? So, given that yan, we have now yung beta, which is the value, which is, this is now equal to 60 degrees. No? So, the problem says, we're looking for the relative velocity. Ito yon, no? Now, in order to solve that one, referring to the velocity triangle, since meron na tayong beta dito, ang wala na lang, in order to find that one, so since this is a triangle and we need one sides to determine ang value ng b sub 1, ang 1 o yung tinatawag nating hypotenuse in terms of a right triangle, no? So, yun ang problema natin, we don't have the b sub n1, no? Remembering, no, from my previous lecture, we have this equation that my volume flow rate, which is inside or on the turbine, so it can be expressed as the equation of that will be 2 phi radius 1, thickness of the vane, and this is the normal velocity 1, and this is also equal to 2 phi radius 2, thickness of the vane 2, and we have the normal velocity 2. Now, since ang volume flow rate natin, no, since sa kanina nakuha na natin yan, so that is 0.565. So we can equate this one as 0.565. So this will be in terms of cubic meter per second. We have the value for that one. Then we can rewrite yung equation in terms of looking the BSN of 1, no? Or the normal velocity, BN of 1. So that will be Q. This will be all over divided by kung ilan yung ano natin doon. Value ng, that will be 2 phi, radius 1, and thickness 1. Or say, we can say that this is now call this equal, no? You can say that this is equal to the value of my 0.565, that is cubic meter per second, and this is all over, no? divided by 2 phi times the radius 1. So that will be 0.6 in terms of meter. And b sub 1, that is the thickness of the vein. From the given, that will be thickness of the b sub 1, that will be equal to 0.01 in terms of meter, no? So this is 0.01 in terms of the meter. Now, using your calculator, so we can solve that the value of your Bn of 1, or let it be the normal velocity at point 1, so that is equal to your 14.987. So this is in terms of meter per second, or say we can round this one into a 15 meter per second. Okay? So, given na yung ano natin dito, yung normal velocity, okay? So, which is given already to the problem. We need to determine now the relative velocity. Now, looking at the velocity triangle, so this is opposite of this angle, no? And this is my hypotenuse. So, from the definition itself, that is opposite and hypotenuse. So, if you're going to write here the SOHCAHTOA, no? So, that will be opposite and hypotenuse. So, we'll be using the sign. So, using my sign here, that will be sine, the angle that will be 60 degrees. And this is equal to my opposite, which is my Bn sub 1 divided by my relative velocity at point 1. Or let's say the Bn sub n1, that will be 15 meter per second, and this is all over divided by the value of which is unknown, the relative velocity. Now we can solve that the value of the relative velocity, pressing your calculator. We may able to determine that the relative velocity is equal now to 17.32. That will be meter per second. Okay, next, we need to determine the absolute velocity in the inlet. So, the absolute velocity, so if you're going to check the velocity triangle, so ito yun, no? And we can solve it since given na rin ang ating Bn sub 1, so this will be your opposite, and we have your hypotenuse. No? So, we can directly solve the value of B sub 1. From the figure itself, no? So again, we can use for letter B, no? So we can use sine also. So it will be a sine of we have here a right triangle, so that will be sine of 35 degrees. So it is equal to your opposite, which is your normal velocity, that will be 15 meter per second, and it is all over divided by my call this the values of we have here the absolute velocity. So therefore, pressing my calculator, the value of my absolute velocity is equal to 26.15. This is 26.15. So this is equal to meter per second. Now next, for letter C, the tangential velocity at the inlet. So the tangential velocity referring to the velocity triangle. So ito yung part na yun. Okay? So this is the side which is adjacent of the adjacent of the right triangle. Okay? With referring to the angle of attack 35 degrees. No? So initially we need to determine, so this is the sum of your angular velocity, u sub 1, and it will be plus to determine that one. Now, so let's try to write the equation for this one. So since this is adjacent and we have here the normal velocity. So that will be opposite, and this will be my opposite and my adjacent here. So for letter C, I have my tangent, no? So that will be 35 degrees. So this is equal to my opposite, that will be 15 meter per second, and this is all over divided by the value of my adjacent, no? Usually this will be the longer one. We have the tangential velocity t1, and minus, sorry, this will be not minus, but or okay, we can minus if we're going to try to minus na, so ito yung part na makukuha natin. Usually it tangential velocity, I can rewrite this one. So let me try to erase this one, okay, and rewrite the equation as this will be 15 meter per second, and this is all over uh, that will be the value of my u sub 1, okay. So from here I'm going to write the unknown here. So I'm gonna name this side x, okay. I'm gonna name this one as an x. So that is the sum of the um, uh, peripheral velocity of the envelope, no, u sub 1 plus the value of x. So that will be plus my x, okay, to get the tangential velocity. And where the value of this one, I can also rewrite here, since this is also, we have a given angle here. So I have my tangent, no? So that will be tangent of the value of 60 degrees. So opposite, I have my 15, no? So that will be 15 meter per second. And this will be all over divided by the value of my opposite, and my adjacent is the x. So I can rewrite the equation as my x. It can be equal now to that will be 15, no? 15 meter per second, and this is all over with the values of tangent, no, of 60 degrees. So that is the value of x. So I can substitute that one dito sa x ng value natin in order to complete the solution to get the tangential velocity, no? But you will notice here, no? So galikan natin ng main equation here, but we can directly solve it. Hindi na natin kailangan pumunta ba doon, but we can directly solve this one by using this equation. Okay, so let's try to do that one. Now, by just pressing your calculator, referring to this equation, so that will be tangent of 35 divided by my 15 meter per second divided by tangent of tangential velocity of the fluid. So pressing my calculator, I have able to get the value of my tangential velocity, which is equal to 21.4, no? So this is 21.4 in terms of meter per second, in referring only on the value of this one, okay. So to determine also yung values of x then, but we can also get this one. If we will try to find the value of the side of this one, we can refer using this equation, since the tangential velocity is equal to the sum of u sub 1 and the plus the value of x. But we can solve it directly, yung value ng tangential velocity, no? Directly using this equation, okay. Now next, hanapin naman, we're looking for the tangential velocity at the outlet. So if you're going to expand going to zoom the velocity triangle at the outlet, so we have this one. So ito yung hinahanap natin. We're looking for the tangent velocity at the outlet. Now, given na yung angle natin at the outlet, we have your angle 2. So that is equal to 85 degrees, no? What we don't have here is the value ng size nito at saka na ito. Now, remembering from the previous equation, this one, we have the volume flow rate. This is 2 phi radius 1, which is also equal to the volume flow rate at the outlet, which is 2 phi radius 2, thickness of the vane 2, and the normal velocity 2, and that is equal to 0.565 in terms of cubic meter per second. Now, we have your BN sub 2, so which is yung value na yun. So, I can say that in order to get yung Bn sub n2 natin, so that will be equal to your volume flow rate. And this is all over by my 2 phi, radius 2, thickness of the vane 2, and this is equal to 0.565, so that will be in cubic meter per second, no? And this is all over. So the value of your radius and thickness, that will be 2 phi, and the radius 2, so radius 2 natin, referring to the figure, that will be 0.2 in terms of meter, and this is multiplied by the what values, by the thickness of the vane, which is 0.05 meter. Okay. Now, pressing your calculator, so for the value of Bn of 2 is equal to, so this is 8 point, no? 8.99, or let's say this can be 9 meter per second to get the normal velocity at point 2. Now, we can use tangent, no, to get the value of my tangential velocity. So I have here to get the value, that will be to tangent na of 85 degrees. So my adjacent here, TOA, so that will be the B2, and this is all over the value of the normal velocity, which is 9 meter per second. So finally, we may able to determine that B sub 2 is BT2, or the tangential velocity at the outlet, is equal to 0.787, so that will be meter per second. Now, to get naman yung absolute, so for the next, we have the absolute velocity for letter E. So this side, no? So this serve as the hypotenuse of my right triangle at the exit. So I have the values. So anyway, kahit saan dito ang pwedeng gamitin, so pwede naman. But I will be using the normal velocity dito. So that will be opposite, and we have here hypotenuse. So again, so it will be for my letter E, no? So it will be sine, no? Sine of 85 degrees. So my opposite, it will be the normal velocity, which is 9 meter per second, all over. The absolute velocity B2. So we're looking for your B2. Okay, and uh, so pressing your calculator. So my B2 now is equal to, that is equal to 9.03, no? So that will be meter per second. Now for my ano naman, letter F, so the torque, no? So remembering that the equation of my torque, so that will be equal to the density of the fluid times the volume flow rate. Then this will be the multiplied by the radius, and we have the tangential velocity of the fluid. And again, that is minus radius 2 times the tangential velocity of the fluid at the outlet. No? So substituting here, so usually the density, since this is water, so that will be 1,000, no? For the value. And multiply by the volume flow rate, so nakuha na natin yon, that will be 0.565, that will be cubic meter per second, and this is multiplied by the value of my radius with the outlet, so that will be 0.6, okay, meter. And the tangential velocity of the fluid at point 1, since nakuha natin na yan, so that will be 21.4 meter per second. And this is minus the radius 2, since the radius 2, it is 0.2 meter. And this is multiplied by the tangential velocity at point 2. So for the point 2, that will be 0.787. So that will be meter per second. Okay. So pressing my calculator, I may be able to get the value that my torque is equal to, and this is now pressing your calculator, so this is equal to 7,000. That will be 165 point 666, or it can be point 0.7. No, so this is in terms of Newton meter for the units. Now for letter G, we have to determine yung work done. So what will be the work done of the turbine? So that is simply as my angular velocity times my torque. No? So since the torque is already kuha na, and we can multiply this one with the angular velocity, where my angular velocity, that will be 2 phi times my 2, 2 phi times n, then that will be your torque, no? Or substituting the value here, we have 2 phi times the value of n, where my n is 200 rpm. So I have here 200 rev per minute. Okay, so converting this one, we have 1 minute, it will be 60 second. Yeah? And multiplying the value of torque, so this is 7,165.7. This is Newton meter. Okay, so cancel yung units dito. So what we have left is already the units of Newton meter per second. Now pressing my calculator, we have now the work of the turbine, that is equal to 150,000. So this is equal to 150,000, 0.78. So point 0.06. The units is Newton meter per second, or that will be the units for watts. So for letter H, we're looking here the work produced by the water. Okay. So remembering the turbine efficiency, no? So that is equal to the work of the turbine, no? All over the work of the fluid. No? If we'll try to expand this one, so usually this is the equation to get yung work ng turbine. So which is already given to the problem, no? For the work of the fluid, so this is simply as we have restating or rectifying equation, that will be work of the fluid, so that will be work of the turbine divided by the turbine efficiency. Now the work of the fluid, so substituting the value of the work of the turbine, so this is how much we're getting. What are we getting? That is 150,000, no? So that is 150,000, 0.78. That will be 0.06. That will be in terms of watts na lang, no? Naka-add natin kaagad yan in terms of units of watts. And this is all over divided by the, call this turbine efficiency, which is that will be 50%, so that will be 0.5. No? So you can find now the work of the fluid is equal to, and this is equal to your value of 300,000, sorry, 300,000, that will be 156.12, no? So that will be the units of watts. Okay. Now lastly, we need to determine the head of water. Okay. For the head of water, so that will be the letter I. Okay. So that will be letter I for the head of water. So we know that the work of the fluid. So this is if you're going to break down yung values na to, so that will be equal to your um, uh, that will be the density, or that will be the specific weight, no? Or this will be the specific weight, volume flow rate, and we have the head, no? Head of the turbine. Okay? And we can specify, break down yung ano nito ng work of the fluid. So this one is the density, gravity, and we have your volume flow rate, and we have your head. So we're looking for your head, so we can say that the equation, it can be work of the fluid, and this is divided by the values ng density and volume flow rate. Okay, so that will be the density, gravity, and the volume flow rate. Now for the head, so substitute natin value. So this is 300,156.12. That is for the units. So it will be uh, 20. That will be Newton, no? Newton meter per second. And this is all over by the value of my density, which is 1000 kilogram cubic meter, and multiply by this one by the gravity, 9.81. This is meter per second squared, and the volume flow rate is 0.565. So this is cubic meter per second. Now, pressing your calculator, we have the head that is equal to 54.15. So that will be in terms of meters. So for the units. Okay, so that concludes the solution for this problem. So hindi naman siya so much complicated. So this is already basic from your trigonometry. And so this is already the applications of call this a combination of fluid mechanics and trigonometry. Okay, so thank you.